In this video, we are going to be working on calculations involving chemical reactions. So I have written here a reaction between aluminum bromide and sodium carbonate to produce aluminum carbonate and sodium bromide. The reaction balanced has a 2:3 ratio between aluminum bromide and sodium carbonate to produce 1 mole of aluminum carbonate and 6 moles of sodium bromide. So the ratio in moles would be a 2 mole to 3 mole to 1 mole to 6 mole ratio. When we work in a lab, we measure out chemicals in grams if they're solids, or if they're dissolved in a solution, or they're a pure liquid, we measure them out in milliliters. The mass of each of these chemicals is based on the atoms that make it up. And so we use something called molar mass in order to convert between the measured amount and then the mole amount, so we can compare one chemical versus another at the formula level. So what we have here is we have the reaction between the aluminum bromide and sodium carbonate, and we have a solution that has 2.500 grams of aluminum bromide, and we're mixing it with a solution that contains 3.750 grams of sodium carbonate. You have to have both of these chemicals present in order for the reaction to occur. They both have to be dissolved in solution for the reaction to occur, and then a precipitate of the aluminum carbonate would be formed. So, given those amounts, we should be able to calculate the mass of all the chemicals that would be present when the reaction ends, because at some point we're going to run out of a reactant and the reaction will stop. So, our question needs to be, which of the reactants are we going to run out of? Because it is that chemical that is going to determine the mass of all the other chemicals that either react or are formed. So just looking at a schematic of this, we would have a solution, and in that solution would be the 2.500 grams of aluminum bromide and the 3.750 grams of sodium carbonate. They're going to start reacting with each other. The aluminums that are in their ion form will find the carbonates that are in their ion form and form a solid. So eventually we're either going to run out of the aluminum bromide or we're going to run out of the sodium carbonate. So to calculate which of the ones we run out of, we have to do some stoichiometry. And stoichiometry is simply when we can take the amount of the chemical and get it into moles so that we can then figure out the moles of the other chemical. And if we want the mass, then we just convert that chemical to mass. So what we need to do is figure out which reactant we run out of first. So to do our calculation, we have to start with the mass of one of the chemicals. So you start with your measurement. So we have 2.500 grams of aluminum bromide. Your goal would be to take your measurement and convert it into moles, so then you can compare it to another chemical. So if we want to convert it into moles, we have to use the molar mass of the aluminum bromide. So the molar mass of aluminum bromide, 1 mole of aluminum bromide has a molar mass of 266.694 grams of the aluminum bromide. This will allow us to cancel the unit of grams of aluminum bromide, and it gets us to moles. When you get into the unit of moles, you can then figure out how many moles of the other chemical we would need to react. So comparing aluminum bromide to the sodium carbonate, the other reactant, there is a 2:3 ratio. 2 aluminum bromide to 3 sodium carbonate. So on the bottom I have the 2 moles of aluminum bromide because I want to cancel out the moles of aluminum bromide. And that gives me moles of sodium carbonate. But we need to have how much sodium carbonate grams we're going to be using. So to get to grams, we use the molar mass of a chemical. So the molar mass of sodium carbonate, 105.988 grams of sodium carbonate, is the same thing as 1 mole. So we're going to cancel out moles, and that would give us grams. So when you multiply across the top and divide by the numbers on the bottom, we're going to then round to 4 significant figures, because 2.500 is 4 significant figures for our measurement. We get a mass of 1.490 grams of sodium carbonate. That is a reactant. And so that is how much would be needed. We can compare that to how much sodium carbonate we actually have. We have 3.70. We can do the same kind of calculation for the sodium carbonate. We can figure out how many grams of the aluminum bromide it would need so that it completely reacted. So we would do the same kind of process. We need to get our mass into moles using the molar mass. So the molar mass, again, for the sodium carbonate is the same thing it is here, but I have it flipped so that grams cancels. Once it's in grams, from grams to moles, we can compare it to how much aluminum bromide we need. So the ratio is 2 moles of aluminum bromide will react with 3 moles of sodium carbonate. This is so the moles of sodium carbonate cancel. I have it organized this way. And then to calculate the mass, I use the molar mass of the aluminum bromide. When you multiply across this top and divide by these on the bottom, round it to 4 significant figures, you get 6.291 grams of aluminum bromide is needed. So if we take the amount that we have versus the amount that we need, only one of these sets of calculations is going to work. So I'm just going to take my 2 measurements, the measurement that I have and the measurement that I need, and I'm going to compare it to what's in the beaker. So in the beaker I have 2.50 grams, and that 2.50 grams would need 1.490. I have 3.750. I have plenty, so I have plenty available. However, if I wanted to react all of that 3.750, I would need over 6 grams. I don't have the 6 grams, so we only have 2.5. So there's no way for us to use up all of our sodium carbonate. And so this measurement that I calculated here, based on the 3.750, is not going to work. It's going to be this much of my 3.750 grams gets used up. So in my reaction, I'm going to end up using the 1.490 grams out of the 3.750 if I use all of the aluminum bromide. So this aluminum bromide, that 2.50 grams, it's going to get all used up. So the 2.50 grams, the aluminum bromide, it's what's called the limiting reactant. And the limiting reactant gets all used up. So at the end, I'm not going to have any aluminum bromide left. And what's going to happen with the sodium carbonate, I have the 3.750 grams of sodium carbonate. I'm only using 1.490 grams of sodium carbonate. So we're going to be left with 2.260 grams of sodium carbonate. There's going to be this much that is going to remain after the reaction ends. So all of the amounts that end up after the reaction ends is going to be dependent on the amount of all this aluminum bromide, because all the aluminum ions end up with the carbonates to make aluminum carbonate, and all of the bromides end up with some of the sodiums to make the sodium bromide. And we're going to do that calculation in the next video.